Okay, so I posted this study guide for final exam a couple days ago. I just wanted to do a quick recording of just some notes, basically some additional points you want to consider as you're kind of going through this final exam as prep for the final exam. Okay, so there's a couple things we talked about. I mean, the final is going to be comprehensive, so we'll be talking about some of the different topics that we've talked about over the course of the term. So, so basically, I want to just kind of touch upon each one of these questions, just to make sure you a little context or know where to look at in the slides or in the notes around this. Okay, so in the last section, we were talking about database administration, right? And some of the things, some of the jobs that a database administrator needs to do. And one of those things is performance of a database, basically performance monitoring. So there's a couple different types of things from a DBA's perspective that you're going to be looking at that you really always may be aware of. So the first thing is this idea of system uptime. How long has the system been up? Um, then, basically, obviously, a system it's not up is not of much use. So, duration and uptime and sustaining uptime is always a critical factor when running a system. But in addition, we also have this idea of data accessing, querying, the speed of a data query. How quickly can we get data out of the system? All right, and that's obviously one of the first thing users are going to see. Obviously, as long as the system's up, assuming the system is up, next thing they're going to be interested in is how quickly they can get their results back. Indexing is, we talked about indexing a little bit. That deals with performance. A technique that we use to optimize the performance, speed up accessing of data, and trying to, and the idea is you want to structure your indexing in such a way so that you get the best possible speed results with the lowest amount of overhead associated with that. And then finally, the last thing the thing you always want to look at is this idea of your performance of your inserts and your updates. All right, if I'm adding data, how long does that take? All right, these are all things that are under a database administrator's control. All right. Second thing we talked about, another area we talked about is the idea of backups and the types of backups that are in the system. So we have things like, for example, a full image backup, which is you snapshot everything. You and then you can recover and you can use that backup as a source to recover the system in case it was damaged or you needed to move another location or things like that. The thing with the full image backup, depending upon the size of the database, that can take a lot of time. All right, so there's two other um, types of backups. One is what we call an incremental backup, which gives you a backup of everything that was from the last time you backed it up. So it gives you an increment. So if you took a backup on Monday, um, if you take a full image backup on Monday, on Tuesday you would run an incremental and would take everything that was done since then. You run the next incremental, so on and so forth through the rest of the week. A differential is basically the third type, which is really kind of, we'll just pick up the differences on an incremental. All right. So the idea is the full image backup you capture everything. Incremental and differentials give you pieces of it, smaller pieces of it, and what you can do is you can use a combination of full image and incremental and differential to bring your system all the way back to a particular point in time without necessarily having to run a full backup all the time. All right, that's really what the um, whole function of this stuff is. All right. We talked about some of the different types of databases, how we use databases, database-driven applications, and things like that. So the obvious ones: client server architecture. We talked about this maybe in some other classes. You might have heard the term in other classes. Basically, you have the the database is on a server. Your client is for example, a workstation, and the client software will talk to the server. The model is you have one server and you have a lot of clients. Web-based application is actually client server, except that we use web technology as the means of providing the kind of the connection between the two pieces, between the client and the server, which is a web technology. And data warehouse applications, data. We talked around this idea of um, creating a large data store specifically designed to do reporting and analysis where we'll collect data from different sources and put it together, and basically anybody can go out there and run queries against it and get the results back. Right? So these are the three main database-driven application architectures. All right. So we talked about some different types of audit controls, things we look at. There's there's a couple of them out there. The ones we wanted to go back and review on, the update and access control, who can do what, to when, to where. The coordination of activity roles, basically who can do, making sure that, if two parties are going after the same resource, that it is handled in an organized fashion. The concentration of resources control, the idea of of how do you manage a centralized resource, that all the data is consolidated into. How do you deal with that? So there's controls and there's things that need to be taken into consideration with that. And then finally, separation of duties. How do you make sure that one person doesn't have the ability to completely on their own do whatever they want? So the example of somebody going in, being able to log into the system, create purchasing organizations, create sales orders or purchase orders, write checks, and then cash those checks. So ideally, what you want to have is you have people who have a scope of responsibility for one area, people who have a scope of responsibility for another area, and you make sure that one kind of is designed to kind of keep a watch or align with the other one. There's a couple different a couple different types of database vulnerabilities we talked about at the end. Of course, we talked about deployment failures. I mean, these are all well-known things. So these are all well-defined scenarios that have been out there. So these are best practices that are out there. So things you look at is like problems with the way you installed it. You do a bad job of installing it. Data leaks or stolen database backups. Backup can be as important as the database itself. Once you get it, because basically you can take that whole data and then take it to another system and restore all the data back, create a whole new system. So basically the security associated with your backups is very important. The lack of segregation, and of other database best practices. All right, so that's kind of what we had talked about before, around who gets to do what. There should not be a single person who can do everything except maybe for the system administrator, and the system administrator needs to be watched. You need to put a set of controls around to watch the administrators, make sure they're doing their jobs correctly. Infrastructure weaknesses, allowing SQL injections. SQL injections are a well-known database attack, what we call attack vector. All right, very well known, and they work. Actually, they work pretty well. So it's a lot of theirs are caused by bad applications or bad systems, infrastructure deployments. Things not being patched, things not being maintained or configured or designed correctly. All right, so those are all things to be aware, and those are well known. What you need to do about how to prevent injections are fairly well known, but they have to be identified. They have to be implemented. And finally, poor encryption key management. The challenge with encryption is it's not so much the encryption whether it works or doesn't work. Encryption works. The problem is that when you take on encryption, you're also taking on the responsibility of managing the keys. If you do a bad job of managing your keys, that's where a lot of problems occur. Either you encrypt something and you can never decrypt it, or you encrypt it and you lose control of the keys and somebody now has access and can decrypt it on their own. All right. We talked about the best practices for database security. So, a couple things to be aware of on that. Prevent direct access to tables. Nobody should have to go directly to a table. You should go to an application to get to a table. Limiting and restricting access to the database server itself. The idea of physical access basically gives you, 85% of the way of cracking the system, 90%. So, physical access is a critical factor. A lot of times gets overlooked. Right? and then following, the procedures, defining the procedures and following. So it's a matter of two things. Number one, you have to define the policies and procedures, and number two, you got to follow them. And you need to do this for logging, patching, and authentication mechanisms. So just um, doing it isn't enough. You really need to design it. You need to document it. You need to follow up on it, make sure that things are being done correctly on an ongoing basis. We talked about some of the different database design terms when we were talking about this idea of data modeling. The idea of a data model being a description of the database, how the data is defined and how it's structured, how it's aligned. The issue with databases are they require a lot of the design work is pretty significant up front. It's not something you can just go in and bebop and slap together. So there's a lot of overhead associated with doing it and doing it correctly. All right. We talked about physical schema. So, the idea of a conceptual, logical, and physical nature of these databases. So the physical database is what's stored on the disks, all right, on the physical replicated or stored on the physical disks can be accessed. The conceptual and logical schemas are those definitions that basically are the representation that we work with when we're working with the database management system. I want to go back. You want to go back and take a look at some of the concepts we talked about with entities and attributes. Remember, an entity is really the table definition. The attributes are the fields. The idea of a composable attribute is one in which you can a single value can be made up of multiple fields, or excuse me, composite attribute is one that has multiple fields. So like your full name is consistent of your first name, your middle initial, and your last name, as an example. We also have multi-valued attributes. So you can have multiple values that can be associated with the same field, and then different types of entity classes. So say, for example, if you have a toy, you have an entity class of toy, and you have different types of toys. This goes back to this concept of object-oriented, where you kind of create something that's abstract and use the abstraction as a basis to do other, more specific implementations. So a toy would be, would translate to an Xbox or a roller skates or whatever, hula hoop, pogo stick, whatever. Okay. Okay. Some of the stuff we talked about with data modeling, you want to go back and just be comfortable with. We talked about the entity relationship models, basically the picture of what all the tables look like. How many tables do we have? What are the fields in those tables, and what's the relationships between all those fields? A unified modeling language, which is really it's a data design language that can be used and for a whole bunch of different things. But it can be used specifically with data modeling, and then data structure diagrams, which is another form of modeling around where the big focus is on the data itself. I want to go back and look at the what we talked about with the normal forms. Take a look at what we said in the presentation on normal forms. The only thing you really want to focus on, I think there's 8. We want to really focus on the first 3. Kind of know what they are. They are the fundamental basis for a working database. So if you can get it to at least third normal form, you should have a reasonable database. You can improve on that with other further extensions, but you need to get it to at least third normal form for a relational database to be usable. We talked about the different types of integrity. Remember, the purpose of a database is to protect data and to make sure that it's correct and to preserve its, as we say, the integrity of it. So the idea of just the definition of what is integrity, and then versus entity integrity, which is, if you recall, that's where every field has to have a unique key. That's entity integrity. So that every row is unique, and the way we make every row unique is we give it a unique key that's not duplicated anywhere else. All right, and that satisfies the entity integrity requirement. Referential integrity is dealing with the relationships between two tables and the primary key and the foreign key. So basically, if I'm linking two tables together, that we have consistency between the entries that are in the one table and the other. So there's not something in one table that's not represented in the other. Right? From a so you don't have a foreign key that doesn't have a matching primary key. Is really weird. It is really where that comes into play, because otherwise, if you had that, you wouldn't be able to get to that particular. You wouldn't be able to find that particular data element, and that database would be considered broken from the perspective of kind of the relational models. We're going to take a look at the different types of ciphers, and we talked a little bit about it, kind of know what they are. So substitution ciphers, transposition cipher, block versus stream ciphers. If you recall, like the block cipher is where we take blocks of data and convert that, versus a stream cipher, which is taking data as it comes in and encrypting it as it goes. We talked a bit about the different types of access, file accesses. So we've got sequential, which is one record next to the other. You read it in order, sequential access method. I have 5 records. I read 1, I read 2, I read 3, I read 4, I read 5. That's sequential. All right. Direct access means I have I can go directly to that record. Or I can go directly. I don't have to go. If I have 5 records and I want the 5th record, I can go directly to 5. All right. And index sequential is something kind of in between, where basically we will use an index to create a, it's not really a direct access, but it's an alternative ordering of the data kind of outside of the actual table itself that we can use as a shortcut to get to be able to access data faster. So we use all 3. We talked about hashing. We talked about hash attacks. So the idea of a collision, things that that people will try to attack hash with, a collision and aliasing or birthday attacks. I think we talked about that in the slide deck. You want to go back and just be familiar with that. Same way with the different types of algorithms, the hash algorithms. Kind of which ones are the most, just basically know kind of what they are and what differentiates one from the other. We talked about this idea of pointers. All right, and this is in relation to data structure. So just to kind of know, kind of what we mean when we talk about logical pointers versus physical pointers versus relative pointers and relative record number. So the idea of this idea of, because basically what the importance of pointers are really dealing with in the actual way we get to data as it's stored on a disk. All right. So what happens is it's all stored in what we call a linked list or a list data structure. And then the way we get to it is we calculate to where it's at, identify calculate to a pointer, and then go to that particular location to retrieve the data. All right. So there's 3 types: logical, relative, physical. All right. Take a look at, we talked a little bit about the different types of commands, but you want to take a look at the select statements in particular, like how how you would do if you want to retrieve data, basically using a select field name, equal to a value, or as we talked about, pattern matching. So pattern matching would be something along the lines of something is like something. And remember, the way that would work would be if you say something is like XYZ star, it means that it'll look for everything that begins with XYZ. If you do look for star XYZ, the opposite of that, it will look for XYZ at the end of the record. And if you say star XYZ star, it'll match any pattern of XYZ it sees in that field. So it's based on a field, it's done on a field basis. All right. We talked about some of the different types of non-relational databases. a lot of these are kind of specialized around with, you'd have for specialized functions or for like what we call big data, so like no SQL databases, not only SQL databases. Hadoop is a particular implementation of those, and also kind of object oriented and kind of this object relational. What you've seen is a lot of like systems like MySQL have gone out and they've just taken um, kind of added object-oriented capabilities, baked them into DBMSs, so it's just there. You want to be familiar with the different types of SQL commands. There's the data definition commands, the data manipulation commands, and then transaction control commands. Remember, DDL is where we create the tables, all right, or we drop tables, where we define the structure of the database. The data manipulation languages is, we either insert data, or we can delete data, or we can update data, or we can select data and find data based upon queries. And then transaction control is, basically where we can either commit changes that we've made to an application into a database, or we can roll them back. The idea is that we've control over exactly when changes are applied to the database. So if something happens, we're in the middle of a 2-hour process, and something unexpected happens and the system crashes, we don't lose the data. Data does not become corrupted. And then just a couple of things to look at. We talked a bit about joins. We talked about a natural join versus a left outer join or the right outer join. Natural join means that you match basically one field equals another. All right, so give me everything where I take two tables and I find the common field I'm going to join them together on, and I match on whatever the value is. Field A equals field B. A left outer join, so when you look at this, you have to kind of think of it in terms of, you draw a picture of two tables sitting side by side. So you have a left table and you have a right table. All right. The left outer join means that you take everything that's in the left-hand side. All right. So if I have 50 rows, all right, I will get all 50 rows from the first table, the left-hand table. All right. And then I will match that against anything it matches from the other table, from the right-hand side. All right. So say, for example, there's only 20 matches between the two tables. All right. So what you'll get is you'll have 50. You'll come back with a result set of 50 items. All right. 30 of which will be null because they didn't match, and then 20 of which will have matches. All right. And then the right outer join is the opposite of that. So the idea is you do the exact same process, except you start from the right to the left. All right. You take everything that's in the right side column or right side table. Everything you take all those results, and then anything it matches on the left-hand side. All right. And then finally, you want to take a look at, we had talked about, database management security activities. I think we kind of wrapped up with that. This idea of, the idea of managing the network ports and the network privileges, and default accounts, and defining controls for concentrated resources. The challenge is, with the known vulnerabilities, the things that organizations always find is that if you just let by default all the network ports are defined out there, that gives a attacker something to work with. It gives them an entryway to say, okay, I can check all the ports and maybe somebody left something open. Or if the port's available, I can see what's at the other end of that port and see whether or not it gives me entry, and I can leverage that in some fashion. All right. So user privileges, also making sure that people have what we call least privilege. People should only have the minimum amounts of rights they need to do their jobs. All right. You can't give everybody access to everything, or a day will come when you will regret that. All right. Management accounts are a lot like network ports. Default, excuse me, the management of the default accounts are a lot like network ports. If you uh, simply install a database and just take everything by default, and you don't secure the ports, or you don't deactivate the accounts associated with the accounts that are automatically added out there, potentially somebody can find a way in and can leverage that against you. And then we talked about, and you can take a look, I think there's a slide out there where we had talked about the controls management of concentrated resources. So those are some of the best practices for how you should approach dealing with um, things like databases, which really are, basically they're examples of what a concentrated resource will be. All right, and that's about it.